So today we're going to do our last lesson for the term. We're going to look at piecewise graphs. So up until now, we've been looking at functions represented by a single equation. However, in real life, functions are normally or frequently represented by a combination of equations, each corresponding to a different part of the domain. These are called piecewise functions. So again, the top of this just restates what I just said, but down here at the bottom, we have a real life example. For instance, movie ticket prices are often different for different age groups. So the function for movie ticket prices would assign a different value or ticket price for each domain interval, which would be each age group. So here at the bottom, we have our piecewise function. So this top portion up here means that the cost is $10 anytime this happens. So this would be that the age is greater than or equal to 6 years. So anybody who is 6 years or older would cost $10 for them to get into the movie theater. However, if somebody is less than 6 years old, so anybody who's less than 6 years old, their ticket price would be $6.50. And sometimes you'll even see a third one. So like your senior citizen discount, you'll see we could add a third line to this for anybody older than 55 or whatever the age might be. So that's an example. You'll see this a lot with different types of tickets. In math, our piecewise functions will look similar to this. So we still have f of x on the left-hand side. And then we're going to have two different conditions here. So the first condition, if x is less than or equal to 1, we're going to follow the 2x minus 1. If the x value is greater than 1, we're going to follow the bottom down there with the 3x plus 1. So keep in mind, we're only using one equation at a time. You'll never plug the same number into both equations. So we pick the equation based off of the constraints over here on the right-hand side. So if our x value is less than or equal to 1, we're going to use the top one. Greater than 1, we're going to use the bottom. So first thing we're going to do is evaluate given different x values. So we're going to evaluate f of x when x equals 0, when x equals 2, and when x equals 4. So the first thing we need to do is figure out which equation that we need to use. Keep in mind that you're never going to use both equations for one single x value. So if we look at the first one, x equals 0, we need to decide if 0 is less than 2 or greater than or equal to 2. So definitely falls under this category here, less than 2. So I'm going to take that 0 and I'm going to plug it in right here. So I'm going to use 0 plus 2, which gives me 2. And that's it for evaluating x equals 0. Then we're going to evaluate x equals 2. This one's kind of tricky here. So x equals 2, we have to decide again which one of these two constraints it's going to fall under. X is less than 2 or greater than or equal to 2. In this case, the greater than or equal to, since it's got that equal to 2 underneath it, we're going to plug our 2 into that bottom equation. So we're going to take the 2 times 2 plus 1. And then we're going to simplify. So in this case, 2 times 2 is 4, plus 1 is 5. Going to repeat this process with x equals 4. For x equals 4, the x value is going to be greater than or equal to 2. So we're going to use this bottom equation again. So the 2x plus 1. So 2 times 4 plus 1. Well, 2 times 4 is 8. 8 plus 1 is 9. Your turn. I want you to evaluate the following. So I'm asking you to find -2. So f of -2 means I'm telling you, hey, the x value is -2. Figure out which one of these two constraints, this top one here or the bottom one here, that number falls underneath, and then plug it into the appropriate equation. So I'll give you a couple minutes to do all of those. So you're going to plug in -2, 0, 5, and 1. All right, for f of -2, the x value here is -2. -2 is less than 0, so we're going to plug -2 into the top equation. So 2 times x, which is -2, plus 1. Then we're going to simplify that. Well, 2 times -2 is -4. -4 plus 1 is -3. F of 0, our x value here is 0. We have to put this under the bottom constraint because x can be greater than or equal to. That equal to is what allows us to use the bottom equation. So 2x plus 2. So we're going to have 2 times 0 plus 2. 2 times 0 is 0. 0 plus 2 is 2. On the right-hand side, f of 5, our x value here is 5. 5 is greater than or equal to 0. So again, we're going to use the bottom equation. So 2 times 5 plus 2. 2 times 5 is 10. 10 plus 2 is 12. Last one down here on the right-hand side, f of 1, telling us we have an x value of 1. 1 is greater than or equal to 0. So we're going to plug in again to the bottom, 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. You will have some problems like this on your assignment tonight. When you do these, I ask that you just type the numerical answer in. So for these, we would just type in -3, we would type in -2, 12, and 4. So we wouldn't type anything else in there like f of x equals, we wouldn't do f of 1 equals 4. We're just going to type in 4 as our final answer. When it comes to graphing, so when we graph these, we need to first of all look at the constraints. So for this top constraint, any x value that's less than 1. So that top piece, in order to graph that, we have to pick x values that are to the left of 1. We'll practice this later. So we would just make an XY chart. And I would start at 1. And if I go on a number line to the left, I would go negative or 0, -1, -2, so on and so forth. To the left. Your numbers are getting smaller as you head to the left. Now remember from algebra 2, when you, or algebra 1, when you graph and something is not included, so that 1 is not included, we're going to use an open circle there. And then our arrow is going to head to the left. All from this symbol right here. So that symbol tells me I'm going to have an open circle when I get to 1. And my arrow is going to head to the left because all of my numbers have to be small. The bottom portion here is for any x value that's greater than or equal to 1. So that's going to be to the right of 1. So I'm going to have another XY table. I'm going to start at 1 and I'm going to head to the right of 1, 2, 3, 4, etc. So again, my arrow is going to the right. And then when I put my circle at 1, this time since 1 is included, I'm going to have a closed circle. And both of these things, again, is because of that greater than or equal to symbol. So let's actually, skip the page. So be aware that you can have what's called a point of discontinuity. So here's a piecewise function here at the top. There is a point of discontinuity. Notice these two lines do not meet up with each other. They don't touch. They're just two separate pieces shown in red. So our graph for this is shown in red, and there is what we call a point of discontinuity. It's allowed to happen. It's just where your two pieces do not match. All right, so our first graph, we're going to graph this piecewise function for any x value that's greater than or equal to 0. We're going to graph 2x plus 3. For any x value that's less than 0, we're going to plug into x plus 4. So looking at just this right here, I'm going to have a closed circle at 0, and my arrow is going to head to the right for this top piece. So I'm going to make myself an XY table. I'm going to start at 0. And since my arrow has to head to the right, so I'm going to have 1, 2, 3. Let's go ahead and do 4. And then we're just going to plug these 5 numbers into this right here. So we're going to plug 0 into 2x plus 3. If I do that, I'm going to have 2 times 0 plus 3. We're going to do the same thing because remember, we're following that same constraint all the way down because all the numbers we're plugging in are to the right of 0. So we're going to plug in 1, 2, 3, and 4 using that same equation. So 2 times 1 plus 3. 2 times 2 plus 3. 2 times 3 plus 3. And 2 times 4 plus 3. So 2 times 0 is 0. 0 plus 3 is 3. So that's going to create the ordered pair 0, 3. And like we said earlier, that's going to be a closed circle. For the next one, we're going to take 2 times 1 and get 2. 2 plus 3 is 5. So we're going to have the ordered pair 1, 5. For the next one, 2 times 2 is 4. 4 plus 3 is 7. So the ordered pair 2, 7. For our x value of 3, 3 times 2 is 6. 6 plus 3 is 9. So the ordered pair 3, 9. For our x value of 4, 2 times 4 is 8. 8 plus 3 is 11. So we're going to do 4, 11. And then again, our arrow will continue on to the right. So we're going to take all 5 of these points and we're going to go ahead and put them on our graph. So 0, 3, 1, 5, 2, 7, 3, 9, and 4, 11 won't fit on my graph. So I'm going to stop right there. Then we're going to connect these. Remember, my arrow only goes to the right. So I'm going to start here, connect them, and let my arrow continue on to the right. Now we're going to go through and we're going to repeat this process for the bottom condition. X is less than 0. So when I look at this, I'm going to have an open circle as 0, and my arrow is going to head to the left. So again, we're going to make an XY chart. We're going to start at 0, keeping in mind it's going to be an open circle. And then we're going to pick numbers to the left of 0. So imagine a number line. On our number line, numbers to the left of 0, -1, -2, -3, -4. This time, when we plug all these in, we just need to take the X value and add 4 to it. So 0 + 4, -1 + 4, -2 + 4, -3 + 4, and -4 + 4. So we're going to find all of these Y values. So 0 + 4 is 4. That's going to give us the ordered pair 0, 4. -1 + 4 is 3. So we're going to have the ordered pair, -1, 3. -2 + 4 is 2. So we're going to have the ordered pair -2, 2. -3 + 4 is 1. So -3, 1. -4 + 4 is 0. So the ordered pair -4, 0. So now we have 5 new points that we can graph, keeping in mind that when we graph 0, 4, we're going to use an open circle. So 0, 4 is right here. I'm using an open circle there because that X value of 0 is not included, but any number leading up to it, getting very close, is included. So next up, I have -1, 3 right here. -2, 2, and all of these numbers are just regular points. -3, 1, and -4, 0. And then we're going to connect. When we connect these, remember, I only have an arrow headed to the left this time. So I'm going to connect these the best I can and draw my arrow to the left. So in this case, we do have a point of discontinuity because I can't draw this whole graph without picking up my pencil, because there's that disconnect right there in the center where X = 0. So this right here is our final graph. Next up, we have h of x equals these two functions If our x value is less than or equal to 1, we're going to use negative 3x minus 1. If our x value is greater than 1, we're going to use negative 5. So I always have a habit of starting at the top. So our x value to the left of negative 1, positive 1, x is less than positive 1. That's going to be a solid circle, and our arrow is going to head to the left. So I'm going to make my XY table. I'm going to start at 1 and I'm going to head to the left. So to the left of 1 would be 0, negative 1, negative 2. Let's just do negative 3. That's right. So we're going to take those 5x values and we're going to plug them into the negative 3x minus 1. So negative 3 times x, which is 1, minus 1. So take a moment and go ahead and find all 5 of these y values. So from this, we're getting ordered pairs 1, negative 4, 0, negative 1, negative 1, 2, negative 2, 5, and negative 3, 8. So again, like we said earlier, we're going to use a closed circle at positive 1, and our arrow is going to head to the left. So we're going to graph all of these, and then we're going to draw our arrow to the left. So 1, negative 4 is our starting point. And then again, when we connect them, we're going to connect them and leave our arrow going to the left. For the second piece of our graph, we're going to use x values that are greater than 1. So any x value that's greater than 1. We're going to start at 1 using an open circle our arrow is going to head to the right. So any number greater than 1. So we're going to use, say, 2, 3, 4, 5. However, when we go to plug these values in, there's nowhere to plug an x value in here. So all we have is -5 for any x value that's greater than 1. What that means is the entire set of y values are all going to be -5. So here we just have ordered pairs 1 -5, 2 -5, 3 -5, 4 -5, and 5 -5 to graph. And then again, when we graph 1 -5, we want to make sure to use an open circle. And then we're going to graph the rest of our points. And then our arrow for this is going to head to the right. Oops. So our arrow in that case will look like that. So here's our final graph. All right, we've got one more to do here. I'm going to give you 5 minutes to work on this question, see how far you can get before you get stuck. So for these two constraints, I'm using x values less than 0 for the left. This should be an open circle over here. Oh. So an open circle at 0. If I plug in 0, 0 plus 2 is 2. Working my way down the list, -1 plus 2 is 1. -2 plus 2 is 0. -3 plus 2 is -1. And -4 plus 2 is -2. So I'm going to graph these 5 points. I'm going to start at 0, 2. I'm going to have an open circle right here. Then I'm going to graph the following points: -1, 1, -2, 0, -3, -1, -4, -2, so on and so forth. Keeping in mind my arrow is going to head to the left, so I'm going to start my line, and it's going to head down to the left in this case. For the second piece, for any x value greater than 0, we're going to use another open circle. And this time, when we plug these in, we're going to take our x value times 3 and then subtract 3. So 0 times 3 is 0, minus 3 is -3. So again, we're just plugging these values into this x value right here. So 1 times 3 is 3, minus 3 is 0. 2 times 3 is 6, 6 minus 3 is 3. 3 times 3 is 9, minus 3 is 6. And last one here, 3 times 4 is 12, minus 3 is 9. So again, I've got an open circle at 0, -3, and then I'm going to put all those 4 points on there, connect them with my arrow heading to the right this time. So 0, -3 right here with an open circle. 1, 0, 2, 3, 3, 6, and 4, 9. And there's the second piece to my graph. Notice in this case, neither one of the endpoints had a closed circle. So they're both open circles in this case. So actually x is undefined at 0 because of that point of discontinuity.